the full stack from AI models to ethical policy and farmer impact. Now, this is my first time moderating an event, so please be gentle and kind. Okay, so what is the objective of this event? So, put my reading glasses on. So we're going to explore how foundational artificial intelligence, AI, can create policy dashboards and advisory hubs for farmers, and how they can function as a single integrated stack for climate action, and how we can anchor the design and scaling of these powerful tools into equitable, ethical, and inclusive frameworks. And how we can then convene technology partners, national implementers, and experts on ethics, and I see one in the corner there, thank you, into a dialogue, and how we can connect a kind of unified ethical AI for climate resilient agriculture. So that's what we want to get out of this session. I hope we can do that. So to begin with, we good?
You're good.
Okay, thank you. So to begin with, I would like to pass over to my colleague, my boss, Todd Rosenstock from CGIAR Climate Action to set the stage for us and be provocative in his usual manner.
If somebody can get away with wearing this kind of suit, then you know you're in the right place. So
I just want to show you my socks. Okay, so I have the climate stripes.
So we're really trying to set the tone here. This is a very open conversation. We expect candor from the panelists. We expect candor from the audience about what's working and what's not. So I was asked to open this panel by Giriraj, and I'm very excited about it because I finally saw a panel called The Full Stack. That's recognized. I was like, wow, it's not just simply this tool or this model, this data, this silver bullet solution that's going to solve all our problems. And I was just...
We are fighting against the elements. You need to hold the microphone.
Okay, so I'll go to my late night DJ voice, and now you can hear me. So we take ourselves very seriously here at COP30, and so I was really excited because we're not only thinking about single silver bullet kind of tools and thinking about how everything starts to come together, and really the question is how we can build systems and models and data that work in an integrated fashion to deliver the kind of outcomes and the measurable impacts that we want to deliver for the producers and for the food system. So at CGIAR, we've really seen that this only happens when we work together, when we work across fields, when we work with policymakers, when we work with data developers and so forth. And so we're really hoping that we get some of these key insights about what makes the full stack work and what makes it fail throughout this session. And we're looking forward for Giriraj and company and Amara and a company to really pull this out. But one of the key things is that, just to be a little bit provocative, is that I want you to think as we go through this session, not about the individual layers that you might hear, whether or not that's a specific AI tool or a specific data product, but really how the connections about these products come together to actually be able to deliver the types of change that we would like to see. And so with that, I'm going to kick it over right to our panel and see what the full stack really is.
Thank you, Todd. That was provocative and to the point. So we're going to hand over to a series of, thank you, lightning demos. Okay, and we're going to show, don't tell through these demos. So we're going to see the AI-powered lens, a showcase of EO foundational model. And I believe this is Andrew Howe, who is joining us online. Yep. So we'll just give the tech team a moment to fire up the system. And I'm going to move.
Hi, everyone.
One more
Can
minute.
someone just let me know? Oh, okay.
Enjoy the sound of ring.
So who has a good joke?
Yeah, I was about to say.
Anyone? Nobody has a good AI joke? Did you have a joke the other night?
Yeah. what was it?
Oh, no, Andrew's
Why-
there. You're
Oh,
saved.
okay. I'll save it for later. I double check what it was.
Great. Thanks everyone for having me. Just confirming you can hear me and you can see my slide. Are you able to hear me and see my slide?
Yes, we are.
Okay, great. Thank you. Good afternoon, everyone. My name is Andrew Howe from AI2, the Allen Institute for AI. We're a nonprofit organization committed to state-of-the-art for good. At AI2, our North Star is quite simple. We think that AI should serve science and society, and inspired by our founder, the late Paul Allen, co-founder Microsoft, philanthropist, we build breakthrough AI technology to help address the world's biggest problems. So along the lines of what Todd was just discussing, this isn't a silver bullet to anything, but part of a broader equation. And by building this breakthrough technology, we have to, and we do work closely with partners. We identify, define, and create exciting and impactful solutions. So today I'm going to talk a little bit about what we're doing in Earth observation to support climate resilience, agriculture, and generally a healthy planet and populations. So despite an explosion of Earth observation from different satellites and such, existing platforms, different models, various products, we're still left with insufficient means to meet the needs of experts, policymakers, communities, farmers to address environmental challenges and support human well-being. There's no shortage of data, that's sure, but our ability to actually use that data hasn't really quite kept pace for a variety of reasons. And so, like we've said, there are different models that exist to address common challenges, but we don't really quite have the scalable and accessible systems to really apply them. So to help fill this gap, we're introducing this OMO Earth platform. It's a comprehensive AI toolkit for global scale insights. And really its job is simple. It's to turn many kinds of signals into timely, trustworthy, and actionable information. So OMO Earth is our Earth intelligence system. It's a foundation model, an end-to-end platform that translates data from satellites, radar, and other sources into clear explanations and predictions. It doesn't just map landscapes or track changes, it can detect, predict, identify conditions and activities that matter most. So let me show you a little bit how it works. First of all, OMO Earth is based off of a foundation model, which is sort of a ground layer AI model that's based off of millions of observations from Earth from different types of satellite sensors. You have optical, you have radar, as well as different types of high quality maps like elevation are imparted into this general model that we call OMO Earth. We then built an entire platform to let practitioners have the ability to adapt the model to their own unique use cases. So these practitioners, you, can add in your ground truth data so that teams can adapt the model to their unique needs. We think this helps empower organizations to go from raw data to decision-ready insights across a number of different Earth observation-related tasks. So let me give you a couple of quick examples of these. In working with the Amazon Conservation Association, there's glad forest loss events that are detected from satellites. That's great, but we don't necessarily know what caused that forest loss. So the expert at Amazon Conservation label events like this using satellite imagery, and they do this hundreds of times. Those labels of these forest loss events are then fed into the OMO Earth platform to create fine-tuned models that detect the likely cause of forest loss in days. So what maybe took an analyst weeks or months, now we can have effectively as soon as these loss events are available. Next, working with the International Food Policy Research Institute, IFPRI, and their partners and stakeholders, we can see how the platform is capable of building high precision crop type maps by using ground truth data collected in the field. With this model that's trained on data from 2023, we can also run it for different years or even seasons. So here we took a look back at 2018 and 2023, and we can see how there's been an increase of cash crops, namely coffee in brown and sugarcane, which is in pink, during that 5-year period. So quite rapid progression of crops transitions. We can also see in the past 5 years how once where there were crops in different land use, reforestation efforts are taking a hold. And so you can see in this part where there's some forest, we see some, looks like younger forests being grown and the model being able to detect those changes. These are just a couple of examples of how working closely with partners, applying state-of-the-art technology can begin to be more efficient, helping address environmental challenges, supporting agriculture, and in general, human well-being. So if you think you have a challenge where you think Olor can help, we would of course love to hear from you and look forward to this discussion and the full stack. Thank you very much.
Thank you, Andrew. Can you hear me?
Yes, Ken.
Thank you so much for your time. It was a great presentation and a bit of feedback. And thank you for joining us online and for your patience. I would now like to hand over to my colleague Giriraj Amanrath to also please give a lightning talk. And
I think I can operate the slide. Okay. Yeah, hope I'm audible. I think we need another AI to pass through between the presentation and the next to turn around there. So I hope, yeah, I think Andrew has provided a lot more context in terms of how Earth observation data models have been built by their consortium. Very fascinating to see that. And in the case of this particular segment, I'll be talking about how do you blend between the field layer and the policy layer, and the role of artificial intelligence is going to be useful. So we represent the CGIAR Climate Action Program, and happy to speak on behalf of all the consortium of partners like Sustainable Farming and the Digital Accelerator Program. So let me move on to, I think one of the example can be, okay, I should pointer. Okay, so what we are trying to see is with the increasing growth of artificial intelligence, I think one of the great advantage of helping is advancing the climate governance framework. What we are trying to see is shocks are increasingly going to be more, coordinations are going to be more challenging. The important way what we can back up is by better technology that can leverage from national level to local level. Coordination, how you can do that better. Often we know each one has their own roles and responsibility, but again, it is quite challenging during a crisis management. How do you coordinate that better? So we are trying to see how different systems can be much more harmonized with the full stack innovation that we would be highlighting here. Okay. How can we go back to the presentation? Okay, no, we need to go back to the previous slides. No, even before. Yeah, you need to go back. Yeah, can you go back further? Yeah. One more. Okay. So I was talking about the what we are trying to do is two set of innovations. We are trying to bring a seamless integration of those technology. One is the policy level innovation. The other one is the field level. And I think Elliot will be more speaking about the equity and ethics part of the innovation. I hope I'm audible. I think we have to keep more closer. Okay. So can you go to the next slide? I'm a bit worried with the pressing. Yeah, one of that in COP28, we have launched a climate smart governance dashboard with the government of Zambia, Kenya, Senegal, and Sri Lanka. And we partnered with the two countries at this point of bringing the artificial intelligence role, specifically with Zambia and Sri Lanka. The idea is we have, let me just go to the next slide. So this is a larger agent that we have built. One is on bringing the climate change scenario, the existing investments, and the future projection to climate change impact, and also partnered with the Coalition for Disaster Resilient Infrastructure. So what these agents are, at this point, we have built with the Claude and OpenAI models to bring together all this innovation into a full stack model. So today, if we know that Sri Lanka is having a water scarcity issues and the existing investment is like $10 to $15 million, what should be the future projection should look like? So we coupled all this model data. I think there is a whole stack of climate risk intelligence model we build in. And this is what we will be launching in the later the week with the CGIAR Pavilion. Now we can look at the entire infrastructure to build a water stress adaptation investment and also the agriculture adaptation investment into that. And we can embed also the seasonal forecast within the same infrastructure so that you could know if there is a GCF is investing at $200 million in Sri Lanka, you would know the next 4 months how the seasonal outlook would look like and what the investment they should plan and in terms of mitigation measure. So this is more to bring from policy to the local level intervention. The other one, what I want to talk about is the Sukha Rakshak, is a field layer innovation, which is built for Government of India. So we have brought in the 4 different agentic models. One is on the drought prediction, drought monitoring innovation, and the contingency plan. And 22 native languages models have been packed into the same infrastructure. So we are now working with the 46 districts spread over 12 states, trying to bring India's first LLM model when it comes to the drought advisory model. So in a brief, this infrastructure is built on Google Gemini model, and we have the the retrieval augmented generation model that has all the vector database provided by the Government of India. In terms of farm level advisory, what you can do, and we have built the native language models into that. So you have an Android version is available already, which is going to go up in Google Play Store in very soon. And this is going to be part of the national initiative called the National Drought Mitigation Program, which is by the Government of India. So we are building, there is no hallucination of the model we are trying to bring because the model itself comes from the native data sets provided by the state level government data, the remote sensing derived data, the drought code is coming from the National Drought Manual information. So what we will see later, a short release we want, because Todd has just taken up the position of program director, we want him to more recognize the innovation that we will be launching later today. So I just want to say, we have two set of intervention we are seeing. One is on the policy aspect, one is on the field level. And what we are trying to bring is how these innovations can bring much more tailored policy impact at the ground level. Secondly, we are also trying to, when we say full stack, we are trying to link the field layer, the policy layer, and trying to make sure that it will bring a lot more robust investments as we go forward. So I'll stop here and happy to hand over to Riaz. Over to you.
Thank you, Giriraj. Excellent presentation. Do we have any apologies? The last one I should have asked, if people want questions, are there any quick questions to Giriraj on the presentation? No? Okay. Maybe later when people have more information. I'm sorry, that's my alarm clock going. Okay, so next I'll hand over to my other colleague, Tech Sapotka, who is going to present on the last mile advisory hub. Thank you.
Thank you. Thanks, Riz. So we heard about the AI model. Now I'm going to talk about our community-based networking approach, and if we can really stack the AI model to our community-based approach, we call it hub model for scaling climate-smart agricultural practices. So in this presentation, I'm going to talk mainly about 3 things. What is hub approach, how it works, and how does it enable the database decision-making process for accelerated adoption, and how can we integrate model into it. If you are thinking about the hub is a project site, it is not. It's an approach, it's a system to bring all the possible stakeholders within a defined agroecological region in a common platform for them to collectively identify what their challenges are and what their solutions to address those challenges are. So at the heart of the hub is a network of stakeholders that contains farmers, researchers, government organizations, private organizations, market players, and so on. They collectively identify what their challenges are and what are the opportunities to address those challenges. In each hub, there is a hub manager, there is a science coordinator, and there is a technical coordinator who collectively ensures a local engagement. They would collectively ensures that the science or research priority is well aligned with what are the local conditions and local priorities are and the overall management of hub. So in the whole hub approach, they follow this 6-step process of identifying the current state or current challenges, and then what would be their desired future state would be. And in order for them to go from current stage to the future state, what are the strategies and actions that they need to kind of identify to address the current state so that they can move from current state to future state. Based on that, they prepare a shared implementation plan with clear objective, action, and timeline, and the implementation plan. And periodically, they also jointly undertake monitoring and evaluation for course correction of the action and also to decide the coordinated investment plan. And this cycle continues in the hub. So this is what about the hub and how it works. It also enables kind of multi-level integration from the plot or field level up to community to food system level up to the environment level. At a community level or at a field level, it is obviously providing all the recommendations, farm management recommendations that are suitable for the farming condition that they are operating in. At a system level or landscape level, it supports farmers and farmers networks and communities to learn and adapt from the changing challenges that they are getting into. And at an agri-food level or at a policy level, it uses data and analytics to inform the policy. Just wanted to highlight that e-agrology, which is a data management and analytics platform that we have in Hub, which is the cornerstone of the Hub approach. So each hub has hundreds of the data points, hundreds of farmers and farmers field that constitutes the data point. All the primary data points that are collected from the field level are combined with a range of secondary data such as climate data, soil data, market data, and so on. And these combined data are used to understand the trend, to understand the status, and these data are also used to train the model, machine learning model, for a range of predictive analysis. And through a series of predictive and prescriptive analytics, it produces a data-driven, climate-informed advisories that are suitable for the local production condition and that are transferred or disseminated to the farmers by means of a platform called AgroTutor, which also has a WhatsApp chatbot built into it so that all these agro advisories are directly sent to the farmers in their individual phone. And through regular monitoring and feedback loop, it also creates a regular learning and improvement in the cycle. That's how the data analytics in the hub works. And then when I'm talking about stack, so community hub approach, if we can, make use of AI on this analytics part, that's how we can make it stack. So I would like to end my presentation with these 3 takeaways. So hub approach, it is an approach to connect people, science and policy. It enables multi-level integration of the technology and action, and it integrates data and analytics to inform the policy. Thank you.
Thank you, Tech. Thank you very much, Tech. Before we move on, are there any burning quickfire questions for Tech on his presentation? Todd, of course, please.
Yeah, thanks, Tech. So great numbers, 218,000 farmers, 1.3 million hectares. What's the logistical challenge to triple that?
I think it is the logistical challenge is in terms of analytics, we can make use of, we can harness the data analytics and the technologies that is coming in, but logistical challenge would be the real implementation even in the ground, which is, you cannot really replace the human thoughts with the technology, like the role of hub manager, science coordinator, or technical coordinator is something that we need to think of, for example, and that are cost a little bit expensive as compared to analytics.
Great, thank you, Tech. Any other questions? Okay, so that was our round of lightning talks, lightning demos. And I see on Tech's last slide, he mentions the word people. Oh, hello. Centea, do you have a question? Yeah. Sorry, thank you.
Yeah, very quick. How do you really bridge the literacy issue? Yes.
That's a very good question. I think, so basically here it is, in terms of technology, it is penetrating even in the illiterate people, right? So even if you go to the remotest place in a community, people would have phone at least, and then they can receive the message. So we have seen that literacy, at least farmers would not be illiterate at all. It can be, all the technologies could be translated into the local language. It is not all in English. So wherever we are working, if we are working in Mexico, a lot of example that I'm showing here in Mexico, it's all in Spanish. If it is in Nepal, for example, it is in Nepali. If it is in India, it would be in Hindi or even in other languages, for example. So the messages, everything goes in a local language. And then by working together, there are, I mean, even in a illiterate, in the remotest place in the community, you can think that farmers are gathering, they are discussing their problem, identifying their challenges, and finding their solutions. And there would be a mix of literate and illiterate people, and they would just learn by working together.
Okay. Thank you, Tech. Apologies. Okay, so I noted on your last slide, you say people there. And so here comes the pivot in the program. I'd like to hand over to my colleague, Elliot Jones-Garcia, who is going to pose some critical questions about the ethics of AI in climate and agriculture.
Thanks, Reese. Have you got my slides? Well, yeah, so I'm Elliot Jones-Garcia. As Reese so modestly introduced at the very beginning, I am the AI expert, ethics expert. I'm not really, I'm trying. I'm here representing the Gender Accelerator and the Digital Transformation Accelerator. And I'll be presenting momentarily our AI ethics, the launch of our AI methods ethical research toolkit with a specific focus on equity and inclusion for AI. I can sort of just read this out. I saw over there somebody presenting with their MacBook to a whole crowd of people, so I think we're not so bad there.
When it comes up, okay, the joke was, why did the climate scientists break up with the meteorologist? Because they had too many heated exchanges. No. There's some tumbleweed flowing in the room. So they, while our tech team. Slides coming? Wrong slides. That's it. That was my one joke. No. So this is learning from. We got them. Okay.
So, right. So as we've heard from everyone so far, AI is reshaping how we generate insights across food, land, and water systems. But it goes more than that. It's changing what we consider best practice and the ethical implications of our work. So the toolkit we designed was to help researchers navigate and change, providing both practical guidance and resources for integrating equity, inclusion into their research. So we took quite a strong lens here, trying to say that AI is not neutral. It's a socio-technical system shaped by gender, race, class, and geography. We talk a lot about how AI inherits the biases of its data, but also its designers and the people who assume things when they make it. And so that's why we wanted to make a very strong point that ethical responsibility is both continuous and relational. It's something that unfolds through the design of an AI, and it's grounded in the engagement between actors, embedded in these kind of things of reflexivity and care. It's quite a dense document, so I do encourage you to go and have a look at it. But I've tried to summarize it here with this typology that we came up with quite early on. And that was to try and understand the different dimensions of research and AI and how they come to interact with for people at CGIAR. So the first, as we might have seen earlier, is research with AI. So that means using AI tools to frame problems, to analyze data or generate insights, generate research about AI, so evaluating their performance, generating ethical principles, and the distributional impacts of AI systems. Sorry, am I standing in the way? And research for AI, so producing data assets for actually training models. So the idea was that this framework helps identify where an ethical reflections come through, not only when we use AI, but how we shape the systems behind it. These challenges are So the idea was that we wanted researchers to be able to critically assess their responsibility throughout building these tools, in particular to steward data responsibly and influence make sure they're representative of women, to test and govern systems in real world contexts. So AI serves equity, looking at majority world ethical principles like Ubuntu. And in short, basically, we wanted to, it's not just about using AI ethically, but about being able to empower researchers to shape the AI futures they want to see. I'm just going to quickly then go through these in comparison to the things we've heard. So Almo Earth, I see as an example of research with AI. On the one hand, AI models like Almo Earth rely on drone and satellite imagery that systematically overlook women's fields on smaller plots or marginal land, producing training data sets that would reproduce existing trends of underrepresentation. On the other, AI systems tend to privilege what can easily be digitalized or quantified, ignoring other ways of knowing, things that might be equally as important on the ground, that is essential for AI adaptation. These challenges are then compounded downstream when survey data, for example, is reused without proper consent, and things may become, you may realize PII becoming available. So this matters a lot for CGIAR and its research, because we sit on some of the strongest data used for training AI for the Global South, and we need to take responsibility for it. Being able to share who appears in the data determines who benefits. Research for AI, so building things for, like AgroTutor, I thought this was a really good example, how you can use this hub model to generate real-world insights throughout the process, to train and improve AI continuously through its development. By evaluating it and bringing in these feedback tools, you can continuously say who benefits, who is excluded, and why. And it ensures that the AI strengthens, not replicates AI expertise, which I think is a really strong point at the end there. You mentioned about how humans still tend to have a real value in the loop. And finally, research about AI. I was hoping that Giraj would actually say this word, but I can't say it, and I didn't pick it up during your thing. But Rakshak AI. I think it was really cool that when you do research about AIs, you were trying to scrutinize model assumptions and bias and explainability. I think for policymakers going to get something, they're not going to use it if they can't see why it's made that decision. So that means why it should be interpretable and meaningful, not this black box input output. So we really will need to be able to see where training data is biased in order to create these things wrong. So as I said, it's long, but just to leave you with this, we should remember that AI systems are not neutral, but shaped by their designers. We need to align AI use with CGIAR's core principles, the ethics that we hold dear, meaning that we have practical, useful tools rather than big, hyped up ideas. We should engage affected communities throughout, as tech has shown us. We should practice reflexivity and care as researchers, not just compliance to tick box activities. And that we should address both structural and technical expectations. That means not just looking at data and like filling the gaps for the data, but actually engaging with people and trying to change things from the bottom up. I like to say that AI systems are built with farmers, not from them. That's me.
Thank you very much, Elliot. Any questions for Elliot on his presentation? No? Oh, yep. Todd? Oh, sorry. We have a gentleman over here. Thank you.
Thank you very much, Elliot. I'm Edward Okoto Moya from the East African Development Bank. I believe AI is the way to go. However, there are challenges with AI, especially from the global south. This is a very high technology, and the common person is what I look at, because our challenge is to encourage the local farmers, the low-income earners, to ensure they have a sustainable source of livelihood through agricultural practices. So how would you integrate the local person? Because you've talked about inclusion. So I would like to know how you would bring the solution down to my people.
Thank you very much for the question. Palabek, I don't know. I've not been there. But as I mentioned to you just a moment ago, I was in Kampala about a month ago. And so I've just spent the last, I'm going to sit way over here to avoid that noise again. I've just spent the last month going between different countries in sub-Saharan Africa, working with different extension organizations and cooperatives to workshop how they interact with farmers. The point being that we can improve the AI themselves in a way that you can take their diagnostic reasoning and in a sense that how they deal with context on the ground. This is obviously a huge problem before you even get to introducing the things, is that a question answer system isn't going to be able to interpret what a farmer needs. It can only respond to what they ask for. And when a farmer's ever going to really actually know what to ask for, right? But it was wonderful engaging in Kampala with the researchers there and knowing quite what is intrinsic to extension in Uganda and those experts. And what it does by bringing people on and treating them like they matter, and particularly in the space of extension where they're terrified they're going to get replaced, is to engage people in making it, and also to make to show the problems about AI and see how they still hold this very strong role. And by bringing people on side and engaging them in a design through these kind of equity processes, it's going to build the ability to scale. You're going to have people, the networks will expand that way, I hope.
So answer your question? Yeah. And then to Todd? No?
Thanks. Cheers, guys.
Okay. So thank you very much, Elliot. Okay. So I'd now like to welcome onto the stage Imara Salas, who is the director of Aim for Scale Secretariat, and Marcelo Morandi, who's head of the Office of International Relations at Embrapa. Thank you. Yes, exactly. I'll pass the mic over to you. I'll sit over here, and I'll eventually pass the microphone to you. Okay, so thank you both for joining us. Okay, so Imara, if I may start with you for this question. So I'm going to change the order slightly. I'm going to go to the second question. So we're seeing rapid advances in AI models for weather forecasting. And what does it take to move from cutting edge research to real world services that reach farmers at national or regional scales?
Great. Thank you so much for the question. Hi, everyone. It's great to be here. So I work with Aim for Scale, which is a new initiative that works with partners, including governments, multilateral development banks, research centers, including many CG centers on the ground, to identify which gaps are preventing innovations from reaching millions of farmers, and then to work together to mobilize financing, technical support, and coordination to facilitate that these innovations can actually reach those millions of farmers. So we act sort of as a broker. We're not an implementer. We sort of step in when it's necessary, when we identify an innovation that we truly think can be tremendously cost effective and bring a huge deal of benefits to farmers. So for the past 2 years, we have been working on weather services. And one of the key lessons that we have learned through this process is essentially the need for benchmarking the AI models. So just for background, over the past, since 2022, there's been a revolution in AI forecasting models, essentially reducing the cost of generating weather forecasts by 80,000 times. So it's ridiculous amounts of time, which essentially democratizes access to sort of gold standard weather forecasts in low and middle income countries, which previously have never had a chance to generate these forecasts themselves. Obviously, we're far away from countries being able to operationalize AI forecasts. Some are, and we're pushing for that, but we're not quite there yet. But in operationalizing this forecast, it's very important to make sure that the models actually work in the countries that we are operating on. A lot of these models have been trained with global data. So we don't actually know if their performance in, say, Ethiopia is as good as their performance in Germany. To give you an example, earlier this year, we worked with the Human Centered Forecast Initiative at the University of Chicago to precisely do this and benchmark the onset of the monsoon in India using to benchmark AI models on their prediction of the onset of the monsoon. So we said, okay, let's try it out. Let's see if these models that have not been trained with local data can actually predict this using historical data. We compared six models using an agriculturally relevant measure. So said, we don't use the meteorological measure of monsoon onset, but a different criteria that is actually useful for farmers. So once it rains, but avoiding the fact that it's going to be a dry spell in between. So the actual monsoon onset that's relevant for farmers, not just the amount of rain that's fallen over a period of time. So I can share more details about that, but I'm not going to dive any deeper. And we essentially found that 2 of these AI models outperformed the others drastically and could produce these forecasts up to 30 days in advance, which is something that the Indian Meteorological Institute up to now does not produce because we didn't know that this was possible and that farmers simply didn't have access to in many parts of India. So through that process of benchmarking for locally relevant metrics, we learned that AI can in fact work for farmers in India. And then we continued working with the Ministry of Agriculture to disseminate these forecasts to 38 million farmers earlier this year. But that initial part, identifying one, the forecast that farmers need. Monsoon onset is critical. It's something that all farmers need. But 2, making sure, and not just vague metrics that are not relevant to farmers. All of that needs to happen before you can get to dissemination at scale.
Okay, thank you very much for that. I was going to pass over to Marcelo, but you said something and I just wanted to do a quick follow-up question, if that's okay. So what kind of evidence helps, you mentioned the government in India, the kind of local, national, what kind of evidence helps build confidence for more investment and adoption of AI from that experience? Just as a quick follow-up.
Absolutely. So this work was actually inspired by, and I'm not saying that all projects need this, but there was a randomized control trial that was conducted in India about 5 years ago that essentially proved the value of delivering forecasts to farmers. This was conducted by researchers at the University of Chicago in partnership with ICRISA. And essentially, farmers received the forecast, and there was an RCT, Ministry of Agriculture. You have Kisan, you have the platform to reach farmers. This is something that's very low cost to do. and that could have huge benefits. We calculated the cost benefit. We did a benefit cost analysis, and we found that it would be at least 100 to 1 in terms of the cost of both generating the forecast and disseminating them relative to the benefits that farmers would be receiving. So I think, evidence of impact and evidence of cost effectiveness are two super important things. But another critical aspect is generating evidence from a different perspective to enhance dissemination. So do A/B testing, focus groups, interviews to make sure that the messages that you're sending out are actually understandable by farmers. Oftentimes we ignore that part, but making sure that the way that you are writing a message, that the time when you are sending it, all of those little details of implementation are critical to ensure that, the impact that you're seeking is actually achieved. So you can go as detailed as that, and
Yeah.
all of that, builds the program.
Okay, thank you very much, Amara. Mr. Tomarcello, we're talking about the benefits to farmers. So from your experience at Embrapa, what is the single biggest bottleneck in making sure that like high level AI data is truly actionable for a farmer in a field?
Thank you, Harsh. Thank you for inviting me to this session here. You can book your compromise before rain or after rain. So we just start this session after rain, yeah, in this season of the year. You asked me about the bottleneck, yeah. We're here working on AI before with agriculture, for agriculture, in agriculture, yeah. But when you think in agriculture on how to help farmers to get knowledge, to get training, and to have answers to their daily questions on farm, the big bottleneck that we have here is connectivity. Yeah, how to achieve the farmers in different regions that we do not have cover with internet, easy internet access to that. Yeah, I think that is different from India, because in India they invest to have the to have huge cover of the over internet to the all territories there. Yeah. Yeah. So here we still have a lack of connectivity in many rural areas. Yeah. And if you solve this, I think that we can really have a big. We already have for farmers to use and to have access to information using AI system and simple AI system. For example, through WhatsApp chatbot that you can ask by voice. You do not need to write, and you receive the answer by voice. And you can receive the answer by voice, not only on your language, but on your own. I forgot the word for that, but because you have different. Yeah. There here sotaque, how to say here in Brazil, different accents in different regions, yeah, for the farmers. So they feel like more comfortable that it's a person that it's from their community that they are answer. Yeah, it's like that. Yeah. So I think no answer. The big bottleneck is to improve connect to give access have now here.
And just as a quick follow-up question to that, how would we incentivize governments to, I mean, the name of this event is the full stack, right? So what is the incentive for the full stack? You mentioned lots of tools. How do we get that as a package?
Okay, so we are trying to solve some of this and incentivize the government side to make some public policy to extend this possibility to the farmers to have access to tools like that. And so now we have one program that is going on in Brazil that is called we have 10 different regions in Brazil that they are using that we put all the infrastructure for connectivity and training people to use the tools. Yeah, by phone more or by computer. And sometimes people don't have access to the mobile, but can use in the cooperative. Yeah, the cooperative has computer home or something like that, and training people, and then they can go there and be trained and ask their questions and receive their positions on that. Yeah, so we are doing that in some regions in Brazil. We have pilot now going on farmers in Brazil. Yeah, because we have 80% of our farmers are smallholder farmers. Yeah, only 20% are big farmers that have their own capacity to do this everything, and so do not need this kind of help. But they use our knowledge that we are developing on AI for other things, for example, for risk assessment and for other tools like that.
And in which point, and I see the clock is slightly against us, but our colleague Elliot was talking about the ethics. So very quickly, from Marcelo, from both of you, if you want to come in on the ethical considerations that come. I mean, you've mentioned sort of the culture, the accent, and things like that. Those risks, also ethical considerations too. If you have a quick thought on that.
Yeah, this is very important because the productive inclusion is the big challenge for us, scale farms. So part of that is already inserted on markets, inserted on cooperatives and so on, but we have a big part that it's out of that. So the AI can help us to bring these people together and to training more easily these people and to put technology to their production and to connect them to markets. Yeah, so I think that this is the main concern. How to use AI tools that we are developing to how include these people and to help.
Thank you so much. One, so we've been so far working on using AI to generate the information that's then disseminated. I think one key aspect of this in terms of, making sure that this is an program is ensuring that these are validated and that we can be as certain as possible. We will never be 100% sure because these are weather forecasts, it's probabilistic information, but we need to be confident enough that we are making more good than harm by sharing information to first. There is a huge risk sharing information with farmers that make about the moon's onset, but there's several other applications that we need to be considering. So I think verification is critical for any type of, not just AI generated information, but I think since it's a new thing that we're trying out now, I think it's a good thing governments are paying even more emphasis on this. In dissemination, making sure that you take into consideration the different user segments that will access this. So for example, that you do test to make sure that the messaging is understood equally by men and by women, so that you don't just test things with male farmers. And all of that needs to be built into the design of the implementation of a project. So I don't think this necessarily applies only to AI. But as we are introducing sort of new tools, it's always worth reconsidering how we've been doing things and how we can do them better. It doesn't matter if the information comes from AI or not, but just rethink how we've been working with digital extension so far. So I don't know if it answers.
No, that's brilliant. Thank you so much, Amara. Thank you so much, Marcelo, for your thoughts and your time and for joining us today. That's the end of that section. Now we're going to have a quick team photo of the presenters and to launch a report, which Giraj can tell us a little bit more about. But before I do that, I will hand over to Todd. Yes, to do a quick reflection on today's discussion.
One more minute. Yeah, so it's very exciting to see the diversity of applications that were presented today, many of which cut across the full stack, let's say that. And so given this is a AI heavy session, I asked AI to have the final word. And what the AI has told us was a full stack without the humans is just a tower waiting to fall.
Wow, that is wisdom, AI wisdom there. Okay, so thank you very much, Marcela and Mala. If you'd like to take a seat, and we'll invite the speakers. Actually, no, stay on stage. Sorry, you need to stay on stage. Marcelo, please come back. Elliot and others, please join us on stage for a photo. And I'd like to quickly hand over to Giraj, who will quickly explain the report that we will be holding in our hands.
Thanks, Reyes, for doing excellent job to moderate this session. You were having a doubt about yourself, whether you can moderate. You did a great job. So we have two part of the report. One is how do we make drought AI innovation model, the technological part of the innovation that we worked with the Ministry of Agriculture. Again, Lara was talking about, again, the role of partnership with the Government of India. We are doing with Sukha Rakshak. So we have piloted that for a few states with the government and with the farmers. So we have some evidence on what we call. The other one is on how the state and the federal government is going to bring a policy integration on this innovation. That's a policy innovation brief we have. So we'd like to take this momentum to share this report here. Pass it on this copies to our colleagues. Come. Without ethics, nothing happens. Join us. So can we have a photo?
Yeah, you'd like to look at the gentleman with the camera. There's one on the left. Oh, okay, yeah.
Also, I remember. Thank you so much.